All right. So, welcome everybody. So we are going to talk about Outlook automation. It's an area that I've started to explore back in 2010 when I was working with one acceleration vendors. So they had the interest to get a tool that was letting them stress test the device. So that's what we are going to talk. So if you were looking for a talk where you have thousands and thousands of Outlooks just showing up on your screen, well, it's not going to happen. We are doing MAPI clients automation rather than Outlook automation, but what is on the wire is pretty similar. So a couple of things about me very quickly. So I'm the CTO of Zentil. I've been running the OpenChange project for more than a decade. So I founded it in 2004, and we have several developers, including Brad Hartz in the here that is working with us at the openchange.org. I've been working on several or contributing to several open source projects, one of them being Wireshark. All of the MAPI dissectors that you have in Wireshark, the MAPI, NSPI, and RFR, I've been contributing them. There are some others, just like the latest version that did not got into that, but anyway. And I have a degree in of Epitech in engineering school. So what is the OpenChange project? Because that is the stack on which the tool is built. So it's a project started in 2004 that is going to implement the entire ecosystem of the Exchange landscape. So we have a client side. So we have a MAPI library on which you can build applications. So for example, GNOME Evolution, the MAPI GNOME Evolution is based on the MAPI. We have several applications that we are providing to create profiles. We have an Outlook, a command line tool that lets you access most of the information, so retrieve your mailbox, access, send email, retrieve email, create contact, everything about appointments too. And we also provide a proxy. And the proxy lets you sit in the middle of an Outlook client and a real Exchange server and actually just interfere in the traffic. So we can just capture the traffic, or we have a stackable modules implementation. And we can just decide that whenever we have incoming traffic, we can just do a deep inspection of the packets, and then just decide whether or not we want to drop or we want to modify the content. So it's a proxy that is going to maintain two connections, one from the Outlook client to the proxy and the other one from the proxy to the remote Exchange server. And we have a server implementation, and the server implementation is what we are working on most of the time. So we do have a coverage of all of the Outlook clients from Outlook 2000 to 2013 included. And with regards to the client library, we are supporting all of the Exchange. We are able to connect to every Exchange server from 5.5 to 2013, including all of the SBS. So there's no limitation in what we can to the kind of Microsoft product that we can connect to today. So we are providing the support for all of the documented RPC calls and also some legacy. But let's talk about stress testing. So first of all, we need to agree on what is stress testing. And what we want is to be able to put a device or a server under a huge amount of stress, so we are able to figure out whether it's going to reply properly or is going to be affected by the kind of traffic that we are sending. And we want to be able to stress a specific part of the product, which means that if we know that it's a no-brainer that sending email is going to work fluently, but for example, for everything related to folder creation, recursive folder creation, we may imagine that there is a point of congestion here, or that may put the server under a huge amount of stress. Then we can just focus on this very specific part. If we stick to the Exchange protocol's word, it means three things. The first one is that we want to be able to generate a lot of traffic at the same time. We want to mimic Outlook as close as possible with the usual operations, or get deeper. And we want to be able to have variables of agitation. So it's more just like control parameters that we can influence to change the behavior of the tool. So that it's not just like we replay the same scenario over and over and there is no change. So but we want to have an environment where we control most of the parameters and we are able just to load more or less. So about the objectives, we want to guarantee that the system on the test is going to meet the customer's requirements, which means that we want to leverage two parts. The first one is obviously we want to test the robustness of the product to guarantee that if you have 500 or 2,000 clients that connect at the same time and have some kind of traffic, that we are not going to experience a degradation, a noticeable degradation of the device or the server. But that can also to expose a weakness, and we can, for example, just have a plugin that is going to be able to focus on a very specific part and show that in a matter of 10 seconds, with 30 clients, simultaneous clients, we can have 30, we can have 50 or 60% of the CPU and the memory that gets consumed on the device. So that helps really narrowing down and try to experience just one very single part. And obviously, if you have a device that have never gone to production, it's extremely hard to provide best practices or to be able to write that your device is going to be able to support that many number of clients. So this way, you can at least draft a very preliminary part where you have best practices, and then you can update it later based on real experience. So, about the Outlook automation challenges. What we want to be able is to emulate client connections that come from hundreds of simultaneous clients and from distinct IP addresses. So we don't want to run hundreds of Windows machines because that is going to consume a lot of memory, a lot of resources. And we don't want either to manually operate Outlook, for example, having automated tested using Sikuli or this kind of GUI, of automation GUI. But we want to be able to customize the scenarios and generate entropy so that all of the configuration parameters can be modified. So in a nutshell, we want to be able to have all of the clients playing scenarios, maybe with some time shift every time, but we want to be able to work on this and to be able, all of them, to have their own process and to have their own existence. But more realistically, it's more just like an Ewok. We want to generate chaos, so we want to generate really user traffic, because if we stick to the metrics, then we are just going to get small variation. If we go to the Ewok world, well, it starts to get more complicated. So the tool is named OpenChange SIEM. So how does it work? We do have the OpenChange SIEM, which is the application layer, which is going to run all of the operations. So this is where we are going to control the scenario, where we are going to control how we bootstrap and how we generate everything. And then it relies on libmappy, which is the client stack that we provide in OpenChange, and that is going to turn all of the API content that we are willing to execute into MAPI-ROPs, and we are going to send all of these MAPI-ROPs over the DCRPC layer for some of a DCRPC layer in Samba to generate the network traffic. And at the very bottom of the diagram, we have all of the tap interface, which means that when we are instantiated a client, we are creating a tap interface, and we are, I'm going to do that later. Anyway, we try to get all of this tap interface to load as many as we have clients, associate single IP addresses, and then execute all of it. In this picture, what we see is that we are focusing on the DCRPC layer from Samba, which means that we are mainly focusing on MAPI-RPC. We have implementation that is going to go upstream into Samba at some point after a lot of code review and bug fixing, but that is going to provide MAPI-RPC over HTTP and over HTTPS. So that will also give the ability to stress test remote servers, hosted Exchange servers, or even to, we are also going to work in the short future onto the MAPI HTTP, so we can stress test also Exchange 2013 SP1. So the source code, it's released under the GPL later. You can download it from GitHub, so you can clone the repository. It has been testing and deployed onto Ubuntu machine and Fedora, but there's no limitation here. So whatever Linux distribution that you are using, you should be able to make use of it. So the main features. We want to be able to generate traffic from different IP addresses. We want a scenario-based environment, which is made of plugin that you can write, and so you can contribute or have your own plugin that you are going to write. We want to have a structured scenario configuration file. I don't want to waste time configuring hundreds of servers or hundreds of configuration files. I just want one main entry point that I can use to just test different systems at the same time and just guarantee that my behavior is relevant. And finally, I want to have a login mechanism to measure the performance. So if I'm sending emails and receiving emails, I want to measure the time that it costs me to run a complete scenario or a complete case, and then see if I have 200, 300, or 1,000 clients, if I had a noticeable decrease of my performances. So the network traffic, we create a tap interface at runtime. Well, not only one, but as many tap interfaces as we have clients that we want to instantiate. Each of these interfaces has its unique IP address, and each of these synthetic clients is using this separate interface. So you can either do captures on a specific type interface or all the interface just to measure the traffic if you want to do then inspection. And obviously, we are doing the cleanup of the interface at termination of the process, which means that we are putting the system back in the state that it was before the execution. So about the network traffic, so this is a capture of, so we are running it against a server. And in this case, we have different modules that we have loaded. So there's the send mail module and the fetch mail module. So the first thing that it's going to do is create the profiles. So let's say that I've never connected to this Exchange server. We are first going to create the profile. And for all of the other users, we are going to derivate the profile. And then we are just, when we are creating the profile, we associated an IP address, and then at the end, when we finish to execute the process, we just delete everything. And below, you have the process listing. So we have the main process, and we fork every time we instantiate a client. So we have, in this case, 3 clients. So we have 3 instances of the tool. So in Wireshark, what does it give? So here that was as in a point in time. So we have on 42 to 154 the system under test, and then we have 2 instances of the client. One is a first instance, and the other one, 2 instances of the client. And we can just see that the traffic comes. It can be random. We don't really care. We just know that we are going to play the scenario a very number of times, and then we can even add sleep or use sleep or generate entropy based on random if we want to even add more timing. But basically, we are going to be able to capture the entire set of traffic. So there are 2 parts in the configuration file that we have. We have the server configuration blocks, and we have the scenario configuration blocks. So if we talk about the server one, it's based, we are going to use a template system. So we can have as many server instances, as many server blocks in the same configuration file. So if I have an Exchange 2003, 2007, 2010, and 2013, I can just have all of them in my configuration file. And as we see on this slide, I can just specify the server on which I want to execute it, and all the tests are going to run. So what the different parameters that we can play with. So obviously the name, but it's more convenient. The real interesting part are the generic user, the user range, and the generic password. Is if I want to generate traffic against 1,000 clients or 2,000 clients, then I need to create all of these accounts on the remote system. So we just use a generic template system. So we use a base, we increment it, we associate a specific password, and we also associate an IP range. So the IP range are using the RFC 1918. So we are using the class A, class B, and class C blocks. And you can define IP ranges that goes from one subnet to the other automatically. When we get out of available IP addresses on one subnet, we move to the next one, and so on. So If we have less IP than clients, then it will stop allocating. And if we have more IP, then great. I mean, you can even run more clients. The version is going to trigger different MAPI behaviors. So at the moment, there's really only two behaviors that we implement. One is if we want to test legacy systems that are only using EC2 Connect and EC2 RPC, so the legacy version that you find in Exchange 5.5 up to 2003, then we are going to be able to use this stack. And otherwise, we can also just use all of the regular EC2 Connect X and EC2 RPC X2 to run the traffic. There are all other variables that we can play on that are not yet available but would be easy to play with. For example, we can play with the encryption, so if we want to encrypt the traffic, or we can play if we want to have the XOR traffic or the compressed traffic. So far, it helps playing properly with many scenarios, but it can be extended. There's no limitation at this point. So the user accounts. So we have one shot. This is where, I mean, the user accounts we've been testing so far during the Plugfest with Exchange 2013 SP1, so using the MAPI over HTTPS. And we encountered some small issue that we are going to be able to solve in the short future. But in a nutshell, we are creating a one-shot profile operation. So we are connecting onto the NSPI pipe. We are sending all of the operations. And when we have one profile, we are going to derivate this profile just using the generate user template. So that works up to Exchange 2013, where my mailbox, I mean, when I have my legacy Exchange DN, then I have all of this random number, I mean, this random hash at the end. So since it's one-shot operation, we could take the opportunity just to, I mean, run the profile creation for 1,000 users, go take a good coffee, and then come back and start to test the tool. So if you want to provision the server with all of the user accounts, we have two ways of doing that. The first one is we have a PowerShell script that just creates the mailboxes. So it was tested with Exchange 2007, I mean, because that was a tool I designed in 2010. But it's also going to work with Exchange 2013 with just small modifications. Another way to do that is we have a library in OpenChange that is called OpenChange PF admin, and that let us connect over the SAM interface, create the user account remotely, and then just listen to the SAM interface to know when the user account is ready, and then trigger the creation of the Exchange mailbox, and then just wait for the Exchange server to tell us that the mailbox is ready to be used so we can move on. So it's a bit slower because depending on the interface, it can take up to 60 seconds before the mailbox is ready. So if you have 1,000 clients, well, definitely your PowerShell script is going to be way more efficient in this case. The scenario configuration blocks. So we have two kinds of scenario, and the scenario are the variables that you can play with. First, we have the repetition. So we can decide how many times we want to play a scenario, and then we have the cases, which means that we can have as many cases per instance of the scenario. So for the send mail, I have two cases, so I'm going to send 2 emails, and I have 200 repetition, which means that I'm going to play this scenario more than 400 times. So every time I'm in an instance, I will go through all of the different cases and perform all the operation. And what we can do is specify an inline UTF-8 body. We can specify attachment, WAR or any, or we can even specify HTML file if we want to use the right stream operations. And for the scenario fetch mail, where it's just like a basic fetch mail where we are going to log onto the server, open the inbox, and then just try to list all the messages and do get props to retrieve the common message properties. Last part is the logging system. So we have a logging mechanism that is based on syslog. So if you want to run several instances of the tool, let's say that you find some limitation on the number of clients that you can run simultaneously on one server, you can run several servers in parallel and just configure syslog to have the remote login, and then you are going to aggregate all of the information. So the information that we are able to retrieve. So it was just made to find that we have different IP addresses and measure the scenario and what are the cases. So you have the scenario name, the scenario name, the IP address. You have the time that it required for one scenario and one case to occur. And you also have the process. So if you need to do some investigation, you can do it from this point. And so that's a predefined format at the moment. OK, the limitations. Because there are limitations. So we have released the 1.0 version. So I just bootstrap the project again, put it on GitHub, change the build system so it's easy to configure, guarantee that it works with the latest version of OpenChange, which is the underlying system we use with. But Exchange 2013 is not supported in the version 1.0. So you can do it manually. With a little hacks, you can do it. But if you want nicely and programmatically to just change the variable into the configuration file, it's not going to work out. So the only version is up to 2010. We don't have the packed MAPI support, which means that a bit like the test suite, we are testing one operation at a time. Because also we don't have the need of packing the operations to retrieve the content. One single call at the time is going to work. So there may be some scenarios for some vendors that want to investigate the packed MAPI calls first, just to guarantee that their MAPI ropes implementation is correct and they can have everything. But in our case, that was not required to stress test a device. It doesn't bring much. We don't have the EWS support. So it's not really a problem except for the auto-discovery part. So if you are stress testing one single Exchange server using the fully qualified domain name, and it's going to work against an Exchange 2013. So in the future, we should bring this on so we can even stress test an auto-discovery web service or the kind of web services, such as out of office or availability service. So we should be able to do that. And obviously, we have a limited number of scenarios. So it's just like a showcase. You send email, you receive email. Now, if you want to extend the tool, well, contributions welcome. It's open source. You just have to fork it. You can, I mean, if you use it for your own purpose, you don't even have to contribute back if you're not interested into. But if you want to contribute, hey, great. We are looking forward to it. So you will be able very quickly to bootstrap a scenario when, if you are playing with contacts, you can list contacts, create contacts, play with name properties, all of this kind of thing. Same thing with appointments. So, I mean, whatever, the only limitation that you are going to hit are the libMAPI limitation that we have at the moment. So that is all for it. So if you want a demo, well, just come by the stand. I mean, we'll really be happy to just help you even set up the configuration so you can leave the Plugfest with the working thing that you can have at your office when you get back home. So just come. I mean, we don't bite, and we even have some free mugs. And well, a big thank you to the Microsoft staff. I mean, you guys have been amazingly helpful, and I mean, everybody has been really helpful in helping us getting here, working, fixing problems. So, well, I mean, I love Plugfest.
You get that on camera.
Do you have any questions?
Have you in your testing, have you defined workloads that you like group scenarios in certain ways to create specific types of workloads against either OpenChange or Exchange?
Yeah, I mean, we are using it to stress test OpenChange. We do have a few bugs to fix. But still, I mean, it's interesting because it's really the problem is that we can't get to production on a large system and just say it and assume it's going to work. We can do unit testing, we can do functional testing, we can do automation just to guarantee that it's going to work. But when it comes to load, I mean, maybe the component that is going to crash is not going to be OpenChange, it's going to be before, it's going to be the backend. Maybe the backend has some limitation and we hit degradation of performances. So, well, the only scenarios that all of the scenarios that are available are right here. So it's very limited. It's send mail and fetch mail. But there's nothing, I mean, scenarios can be written in just a matter of 1 hour. 1 hour you can have your working scenario out there. So.
But I mean, in terms of like, so you have those two scenarios. like put a workload around them in terms of like, we're going to do this much mail at this time, break, more mail, fetch, like kind of in a sequence like that? Is there like a way to configure it so you can kind of run a normal day's workload?
Good point. We don't get to this level of details, but guess what? We could possibly just add an attribute which is a time range, and just bootstrap the scenarios. Yeah, just like specify range of hours, and whenever we hit in with a timer, we just load. Yep.
Julian, do you try to simulate Outlook connections? Make certain number of connections, more than one.
Yeah. So the alter context is not supported. So it will just be plain connections. So, for example, if your Outlook client is going to use multiple logon ID, we don't support it. We just because that's a limitation of libmappy, mostly, more than a limitation of the tool in itself. So fixing libmappy, fix the tool.
Can you stress address book connections?
Well, yes. I mean, there's no problem with that because we can log on every single pipe. So we can log on RFR, on NSPI, and EMSMDB. So yes, we can stress NSPI.
And you don't try to simulate certain Outlook clients, just generic connections?
Yeah, these are generic operations. We could try to mimic a very particular Outlook version based on Wireshark captures and try to identify a behavior that is not the same but with a different version. But definitely, if we go to this level of detail, from my point of view and from the product that we are developing, it doesn't make that sense because we know that it's not going to have any impact on the behavior. Now I can understand that from Microsoft point of view or from a vendor-specific point of view that are really doing this kind of thing, it can have an impact. So yes, there are limitations definitely, but it could eventually be triggered just by the version. So by the version, we can just specify that we want to add a ROP pending ROP in the middle of the flow, or we want to add a ROP backoff, or.
It's very difficult to trigger even an exchange. Yeah. That's very cool. It's a huge amount of work.
Cool. Other questions? If not, thank you very much.